Before interaction, let's create a material. This 4-plate material, general input mass density, a mechanical elastic. So from this type, select engineering constant and put this traction property material definition. So if you need, here is the property in this paper. You can refer from this part. Copy this part, input this constant, okay, then create cohesive part, then go to in mechanical, and here damage for traction separation law, and here select quads damage, that's quadratic damage initiation. Whenever the cohesive material used as the reinforcement in composite material is quadratic damage initiation property with so this is the value as per your material. You can put here, then damage evaluation, so in type energy, then here mixed mode behaviors, power law, so under certain so here in mechanical elastic, then in this isotropic type, change this isotropic into traction. Okay, then create section, top cohesive, this other, and select cohesive. Material is cohesive, then response traction separation hub. Okay, then no need to change this one, just create section 2, bottom cohesive, as it is other in other category, and cohesive type. The material is cohesive, traction separation, okay. Then other create solid homogeneous top plate, bottom plate, and finally is bottom, top, and middle. Okay, assign for each part top cohesive. Select this section assignment, select all, then create this bottom cohesive. Bottom plate, select all body, then select this bottom plate from the create section, middle, okay, all parts are assigned, so go to top plate C. Okay, I finished. Go to interaction. Let's magnify this part. Create interaction property, contact interaction, and in mechanical just select this tangential behavior, then frictionless as it is the default property. Save it. Then before any interaction property, before creation of this constraint, let's go to surface. Just create 8 surface here. Go to this display group and remove this top cohesive and bottom cohesive. Remove this part, then create surface, top plate, surface, select this edge. Okay, similarly create for all 4. Okay, we created this 4 surface. Then go to this invert display. Then we'll have these 2 cohesive materials. Similarly create a surface. Top cohesive, top surface, this edge. Okay, we have created here bottom cohesive top, bottom cohesive bottom, and these 2 for top cohesive. Then add this. Also we have 8 surface, and go to this constraint manager and create tie constraint for this 8 surface. So the first one, for example, you see surface as a master surface, choose instance, this bottom surface of the bottom plate, this one, bottom plate top surface, continue and select surface for this bottom cohesive bottom surface, this part. Okay, create. Okay, I have created this 4 constraint for each, for interaction, for group of surface. Similarly create here interaction surface to surface, contact explicit, top plate with surface of top cohesive bottom surface. For bottom plates, then the surface of bottom cohesive. Okay, I have finished all the interaction here. So go to load. Okay, step already created, so go to load. Okay, in load you have this one, boundary condition 1, create, and the constraints in X direction. There is no translation moment in X direction, so select these two nodes, this corner and this bottom corner, then constraint in Y direction. So in boundary condition 2, if you select this point and upward, we have 0.45 vertical displacement in Y direction, and this point magnitude equal to this one, this 0.45 downward. Okay, then go to mesh module, in part instance, this bottom cohesive just have 0.00115 global element size. Apply the part, you change this one quadrat structural and minimize mesh translation. So this apply element type is standard and select from this family list cohesive property, cohesive family. So okay, then mesh. For bottom, apply 0.0015 and similar quadratic structural element, then mesh this part and select element type. So from this element libraries as it is standard, so we change this one plane strain. For middle, do the same. Think element plane strain. Okay, this top cohesive element size 0.0015, apply, then mesh it and choose material type, this cohesive, so choose this part cohesive. Then go here, top plates 0.0015 global size, apply, then mesh and assign the material to plane strain family. Okay, okay, finished this meshing, so go to job, and before that let's go to property, then create orientation, material orientation for this anisotropic material. So create this orientation, select the part. Okay, then use as a default orientation. So just accept the default, then similarly select this part, bottom plate, use default method. Okay, then for middle, top cohesive, default, then for top cohesive choose this part. Okay, then go to job module, job, and create delamination analysis. Okay, then check for data first. Before submission, you can check the data. So if some warning is there, we'll edit. Okay, the analysis is aborted. Let's monitor the reason. In error, what it says, the power is not specified in specified values equal to or smaller than 0, it says. Okay, let's go to material property, and choose this cohesive material, and this in damage evaluation there is power. We select power low, so put this one value greater than 0. Okay, then go to job and data check again. Okay, the data is okay, so submit for analysis. Let kill this, terminate this analysis, and let's add one thing here. In step module, at this set, at this net, go to history output manager and create in step, choose set from domain, then select set to this set, then in displacement let translation we need to find y direction, then in reaction force, the force acting in y direction. Okay, and also let's change this boundary condition, it may distort highly, so let's correct this one, 0.045. okay, and also here 0.045 displacement in downward y direction, then submit. Okay, the results completed successfully, so go to results and view in this way. So look how the delamination looks like. So in view ODP display option, you can sweep extrude, and you can add some value, depth, and you can see like a 3D visual in this way. So in visualization what you see in this straight, if you look at this one, the blue is cohesive and this one is the bottom cohesive, and this middle one, the bottom, I mean the middle plate. So this how delaminate. If we apply force or displacement upward and downward, so in output request delamination, you see history output, we need to run this special displacement. Plot this displacement look like this. So if reaction force, this one, so plot this, you see force with time. To draw displacement force graph, select these two, then right click and save this path as it is. Okay, then create here graph, then operating on XY data, then combine this two parts. In X we double click in displacement, and in Y double click here in force, then plot expression. So here displacement with forces looks like this one. Okay, thank you everyone, thank you for watching this today's video. If you want more videos, subscribe the channels. Thank you.